welcome to another Asymod video. Here we have Keith's and Ralph's RCI 2995 DXCF, and we've installed the DARP package, the DARP, on both with the DMod, Asymod recorder, and high-low power control. An additional thing that we've installed in these builds is the rear control panel, or the rear panel, which gives you the RF sampler output, amp keyer, the transmit and receive record output, your line N, and your VFO Whine. Now, we installed a Asymod Enable and Disable switch. Ralph wanted that function and we went ahead and installed it. This way, when you disable the Asymod, the radio is 100% back to factory specs. It operates with its front RF power control while on AM, and everything else is the same. The Asymod's completely bypassed. Taking a look at the inside, we've installed the Asymod 7. We've also installed up here in the front the display filter right here. Takes away that motor-like noise from the receiver. We've installed our recorder and all the DARP controls in the front speaker grill, and we've moved the speaker to the bottom panel, as seen there. In this build, we've also upgraded the main filter cap to a 10,000 microfarad. Seen right there, 25 volt low ESR cap. Here on the bottom side of the radio, we've installed our RF demodulator coming out of the front panel controls into the radio's audio amplifier. We've installed our DMod pickup toroid transformer and the DMod circuit, and we have the RF sampler pickup transformer right here. We have the PA jack converted to PTT jack. This is your VFO delay capacitor. That goes to the other circuit right there that enables the frequency shift to create the heterodyne effect. That, in other words, is your VFO Whine effect. And finally, we have all the other mods necessary for hi-fi receive and transmit. We've rerouted most of the cables back here to make it nice and neat. The Ranger RCI 2995 DXCF DARP built with the Asymod 7. So now we'll go ahead and give it a little test, see how it performs. Hello and welcome to another Asymod video. Today we're going to be testing out Keith's and Ralph's RCI 2985 DXCF DARP. Here we're going to be recording on the PC and give it a little test run using Pro Tools. Then we're going to use the Static 575, and then we'll use a standard hand mic, see what it sounds. We've also installed the Asymod Enable Disable switch. So by the flip of a switch, you can just disable the Asymod and start to use your RF power in the front panel, and the radio will be back to factory stock. While running Pro Tools, we'll be using the EV RE20 mic. So here we'll see how the asymmetrical control works. The asymmetry gives loudness to the audio by raising the positive peaks in the modulation and maintaining the negative peaks at 99%. Right now we have it tuned for 100% modulation. So we'll see first the carrier. Over there we have it set for 5 watts, as you can see. It's a 5-watt carrier. And we have our 2 divisions here. Now we start the signal generator. And we see we have our perfect 100% modulation here. Very perfect envelope. And we have 0 asymmetry over here. So as we raise up the asymmetry, you'll see our envelope starts to raise. That's 150, 200, 250%, almost 275. Back down to 200, back to 100. We could see here on the meter now, and 100% modulation, we have about 16 watts PEP power. 200%, we have 30 watts of PEP power from a 5-watt dead key. And at 275%, we have 50 watts of PEP power out of a 5-watt dead key, meaning 250, 275% is 10 times our carrier power in PEP. Back down to 100, we see our 16 watts again. 275. Here we could catch both modulation envelope and the meter. Down to 16 at 100. Up at 75, 50 watts. So there you have it. The Asymod 7 asymmetrical AM modulator also gives you wideband audio, 15 kilohertz of bandwidth that can be rolled off at any roll-off point using your audio process chain. Okay, first we'll start by trying AM with the Asymod on to make sure everything works correctly. So we'll go to AM mode. We're going to be keying up with the microphone instead of the PTT mouse, but we're using the line N from the Pro Tools. Switch, let's put it to the Asymod position, which is to the N position. Make sure our VFO Whine switch is off, and let's go ahead and key up. And looking at the scope here and the meter here, we're on a 50-watt slug. So 2 lines will be 2 watts. When we key up, let me kill the audio. That's the tone, the audio, okay. So here, now we have the 2 watts of dead key, and we have a reference on the oscilloscope, 2 gradients or 2 divisions for the 2 watts. And we're gonna go ahead and start the SIGGEN inside Pro Tools. And we have it set for about 804 hertz. We'll lower it a little bit there, around 732. Okay, so looking at the scope here, we're over modulated. We want to get rid of that flatness, so we bring down the modulation on the radio until we get that perfect round curve down there. That's our 100% modulation. We take out the audio. We're left with the carrier right there. Modulate, we got our 100% modulation. Again, with the asymmetry is your loudness, so you bring that up, and as you bring it up, your asymmetry makes your positive peaks rise above 100% modulation. That's 150, that's 175. We'll leave it around 130, 140. All right, so one key, and that's working fine. Okay, so now we'll go ahead and do a small recording. Make sure we take our signal generator off and we turn on our mic, key down, test 1, 2. We're a little low there on the input to the recorder. Audio 1, 2, but we're doing our 150% modulation at the moment. Okay, so here we are running our Asymod 7. We're going to go ahead and do a voice test now. We're going to key up. And we're going to use the Pro Tools with the RE20. This is a test recording the RE20 with the Pro Tools, running the Asymod 7 and the RCI 2995 DXCF. This is the RCI 2995 DXCF running the Asymod 7. As we record here in Pro Tools, we can see our audio is nice and clean. We have a very nice carrier and very nice envelope as well. Audio 1, 2. Okay, so right now I just lowered down the asymmetry. We can raise it up a little bit, and as you can see, immediately it starts to get a little louder. Audio test, audio test. 1, 2, 3, 1, 2, 3, 4. So let's bring it back down to about 125, 150. Okay, so now we're gonna go ahead and try it with the static 575. If you could find one, good luck, but it's a great microphone. It's got volume and tone controls. So this is the RE20. Let's go ahead and switch over to the 575. We just simply unplug the 1/4-inch line end connector. And now we're on the hand mic here. Test 1, 2. There's what the test. There's what the mic sounds like. Obviously, you can see stray peaks, out of control, with no limit or no compression. As where the processed audio is from here and before, you can see our peaks are regulated, so that allows us to not distort while we're on the air. That's why it's so important to have processed audio. Okay, so this is what it sounds like with the static 575. Now we're going to try a standard mic and see what it sounds like. Okay, here we have a standard hand mic, and as you can see, we still have about the same modulation readings on the oscilloscope, but when you see the audio here, you can see how uncontrolled that is, and that causes distortion even if the oscilloscope is not fast enough to see those negative peaks. Audio, there you saw it. It goes out of control there. So that's why it's recommended to use processed audio, and if you don't, be very careful where you set your gains, your audio gain. Okay, so let's go back to the processed audio and connect the 1/4-inch line, the 1/4-inch line end connector. Audio 1, 2, 3, 4. That's our processed audio right there. And we'll go ahead and test out the demodulator now, and we'll record straight out of that. We're going to be using this right here. It's the 1/4-inch to 1/8-inch jack adapter that I have, and we'll test it out. Now we'll go ahead and install this 1/4-inch Y adapter to a 1/8-inch connector to feed the computer for recording. The other 1/4-inch output would be for my headphones, so I could hear the demodulated audio. So I'll take my headphones, disconnect it from the IC706 MK2G receiver, and plug it into here. Now I'll be listening to my transmitted audio as well as recording it. Okay, so let's go ahead and plug that into the computer, and we'll go ahead and key up. Audio test 1, 2. We'll need to raise up the output of the demodulator a little bit. There we go. Right there we can see we have just about right on the computer, right input gain. Let's span it out a little bit so we can see the detail. Let's see over here. Okay, so there we go, see the real-time span detail. Okay, so that's what it sounds like using the demodulator. We're doing right now a 2-watt dead key swinging to about 8 watts, which gives us about 100% modulation. We're doing right now about a 2-watt dead key swinging to about 10, 15 watts, doing about 150% modulation. Audio 1, 2, that's 100% modulation. We could bring up the gain a little bit there. And that's 2 watts swinging to about 8 watts, 100%. And then when we raise it up the asymmetry, as you can see, our audio just got louder. And there we're doing about 10, 12 watts PEP. And that's what it sounds like. Using the demod function, you could actually hear yourself exactly what you sound like coming out of the air. And you can do all your adjustments without having another radio filter out your important parts of your audio spectrum that you need to listen to. So, okay, over here we have the high and low power switch. At this moment, we're doing low power. When you key up, the green LED comes on, and when you go on high power, your red LED comes on. And of course, now all our settings are out of whack because we're running high power at the moment, but we still sound just as good. We'll go ahead and adjust our reference here. Let's see, bring that up to about 5 volts per division. Audio 1, 2, 3, 4, 5. There you go, audio 1, 2. Let's raise up the asymmetry. As you can see there, we're about 150% modulation. Audio test 1, 2. To bring it back down to about 120. Okay, so there you have it, the Asymod DARP with the new rear panel. Hope that Keith and Ralph enjoys it. And now let's go ahead and test the VFO Whine. For that, we disconnect our demod and go back to our headphone jack to receive on the IC706 MK2G, and we'll put it on sideband, and we'll be here on AM. We'll turn on the VFO Whine, and when we key up, we'll start transmitting off a few kcs off the fundamental. Within 3 or 4 seconds, we'll drift into the fundamental frequency of the channel, and that's what creates a heterodyne effect. When 2 signals collide on air, a third party gets to hear the so here you have this radio is on sideband, this radio is on AM with the VFO Whine enabled. When you key up, the only reason we're on sideband is because we don't have a second AM steady signal to see the drift, but on sideband we're able to hear it somewhat. Doesn't sound exactly as good as it does when you're on AM.
EW, RCTY, USB, LSB.
But let's see on lower sideband, we key up. There you have it. Okay, so right now we're gonna go ahead and turn off the Asymod. We're gonna disable the AC. Right now we're gonna go ahead and disable the Asymod altogether. So we'll flip the switch to the outside position. And right now the Asymod is disabled completely. We're on AM. We'll set our receiver to AM as well. There you go. Now when I key up, this carrier control is no longer functional. The Asymod is totally disabled. Now your RF power control of the radio is what works. And you won't be able to use the line-in connector, although it is connected. You'll have to use the hand mic as I'm using right now. And this is what it sounds like with the standard hand mic. Let me go up here, chase the recording down. So there you go. That's what it sounds like here. As you can see now with the standard radio, when we talk, and we could, we're doing 2 watts right now. When we talk, when we get to when we get just to 100% modulation, we see the flat lines there. Let me see if we could audio. See the flat line right there. Audio. You don't get that with the Asymod. So let's put it back here again, and that's a little bit under modulated. If we raise up the mic gain a bit, audio 1, 2, audio, you start to see that even you start seeing the troughs get really distorted. Now that's a stock microphone. It sounds really bad. Audio 1, 2, 3, 4. That's what it sounds like. The standard radio. All the controls in the front panel is normal. Your power control, your mic gain control. So now we could try out another radio. We could try out the static 575 using the radio that is stock to see what progress it does. And here we have the static 575 microphone connected to the standard radio. No Asymod involved. Now let's flip the Asymod on using this mic and take out the 1/4-inch jack just to put the microphone on here. And as you can see, it sounds a lot broader, more wideband. Audio 1, 2. The mic does have a tone control, so that's a high pass filter right there. Most of the highs are going through, barely no low end. And as we adjusted here, we have more low end on the static 575. Now that's the static 575 with the Asymod on. Now let's plug in the processed audio. And that's what it sounds like using the processed audio. As we transmit, I'm keying down with the 575. Audio test, 1, 2, 3. So a lot of folks wanted to hear the before and afters. I'll be more than happy to do it. Audio 1, 2, 3, 4. Audio test, 1, 2. All right, the Asymod 7 and the RCI 2995 DXCF Hi-Fi AM and eSSB transceiver.